right, so it has actually been a while since you've seen the mic around the neck here because we haven't had to record too much. But I left myself a post-it that I was supposed to redo this one, so we're going to. So first we are going to actually derive these. These are called double angle formulas. Okay, as you can see referenced right here. And that's because the angle, which is theta, is being doubled. They were very clever with how they came up with that name. All right. Now, to show you where it comes from is actually quite simple, which is why we are going to take the time to show this one. And so if you look at it, we can actually use sines, because what's another way I could get to 2 theta? Instead of taking 2 times theta, I could actually just take theta and add a theta. Do you agree with that? And so if I do that, now it's just a sum or difference formula. And we have that formula for sine. Okay. It's on, what, 7/3 notes. And what that says is to take basically sine of the first one, which is, well, the first one right there is theta, right? And then cosine of the second one. Well, the second one is just that theta, so they're the same. And if you remember, in sine, the sine stays the same, right? So it's plus. And then you would take cosine of the first one, which happens to be theta, and sine of the second one, which is, again, theta. So what this means is sine of 2 theta can be written as whatever that simplifies to, but they're all the same angle. So on the left side here, I have sine theta times cosine theta, right? Plus, well, isn't this also sine theta times cosine theta? So really, how many of those do I have? I have 2 of them. Some of you, your brains might be like, you know what, I've seen that somewhere before. That was on that early math placement tool. That was one of them towards the end. They wanted to know what sine of 2 theta was equal to. Okay. And now you're saying, well, wow, that's wonderful. That's not all that helpful. But here it actually is, because look over here. This says 2 theta. What do all of them on the right-hand side say? They just say theta. So I can go back to the original angle before it was doubled. And this will give me the same answer. Again, on the one on the early math placement tool gave you like 4 options, right? That's where I told you just put in angles and see which one works, right? But here now you've seen it. So any place that you see sine of 2 theta, you can replace it with 2 sine theta, cosine theta. Okay. Again, it is actually helpful because it is just theta. Okay. So any questions on that one? And really deriving the other formulas is actually very similar. The next one you have is cosine of 2 theta. I don't really want it to say 2 theta. I'd really rather it was just theta, the original angle. And so let's just do the same thing. Make it theta plus theta. It's another way of writing 2 theta. But that's a sum and difference. And that says take cosine of the first one. Again, that'd be the first one right there. And cosine of the second one. So that'd be the second one. Anybody remember what would come next for cosine's formula? Just from doing it so many times? Minus. Yeah, I get that, right? You kind of figure them out after a while. And then sine of the, again, first one. Sine of the second one. Again, all of these are just theta. It's no longer 2 theta. So what do we got here? Cosine of 2 theta, well, this term right here is just cosine squared. You want me to do the theta and then in parentheses squared, or just write the square the kind of lazy way? Lazy way is okay? All right. Right? Minus, well, this term over here is sine squared. So once again, any place you see cosine of 2 theta, if you want to, you can replace it with cosine squared minus sine squared. Of course, remembering that technically cosine squared is cosine of theta squared. That's really what it means, right? We just wrote it kind of the lazy way. This one actually has a couple other versions. The sine of 2 theta only has the one version because it's the simplest. This one actually has 2 other versions. Okay? because you can use the sine squared plus cosine squared equaling 1, you can manipulate things. So for example, we know that to be true, right? And so if I wanted to, do you agree that's also true? By just subtracting cosine. Or if I wanted to, from the original, I could have done this. Right? These are all true. They're just manipulations of the same thing. Okay? So what I could do is with this one, if I wanted to, right down here, I could replace cosine squared with 1 minus sine squared. Do you see that? If I did that, so write that as 1 minus sine squared minus another sine squared. So it actually ends up being 1 minus, somebody said, say it, 2 sine squared. So that's another option. So for cosine of 2 theta, you have this option, or you have this option. It's also true. It's just a manipulation of it. Or if I go back to this one that we started with, I can replace sine squared, right? Okay. And if you do that, I'll just write this one down for you. Yeah, which one haven't I written down yet? That one. It becomes so there are your 3 options for that one. And then you might be asked, well, how do you decide which one you want to use? Well, whichever one fits the problem better. Unfortunately for sine, you're kind of stuck. Sine of 2 theta, you got to use the one you got. So cosine, 3 options. And this is just a good review of the sum and difference formula and some of the other identities. So yeah, you have whichever one. I see somebody's still writing, so I'll let you finish up. Any questions so far? Okay. The tangent one, actually, believe it or not, usually tangent's kind of more difficult, but this one's really not too bad. Pretty good. I can come back to this slide if anybody needs to write it down. So tangent of 2 theta could be written as that. This will be a true test of how well you remember things. I think yesterday was the first time you really had to use this one, right? But again, the first angle and second angle are the same, so that's helpful. So in the formula, tangent of the first one, which again is technically that one. Anybody remember now? Yeah, it stays. It's the same, right? This top one, if it was plus, it stays plus, and we did have plus. So plus tangent of theta, all divided by, very good, 1. Yep. Yep, this is the one that switches. Yep, this was plus over here. Again, I'm putting all the arrows because I'm recording this. Otherwise, I wouldn't have to. Minus, and then tangent of the first one, tangent of the second one. So this one's not too bad. As far as deriving, it's still not pretty. Yes. Yes. Yeah, that's actually a question that second hour asked yesterday too. And for the recording, if you didn't hear that, the question was, do you have to use the tangents formula, or can we always kind of revert back to sine and cosine? And yeah, you don't really have to use the tangent formula. There are instances that it does speed things up for you, but if you are comfortable with sine and cosine, you can always go back to those. Yep, great question. And so what do we get with our numerator here? Well, there's 2 of them, right? So 2 tangent of theta over 1 minus, yep, tangent squared. Very good. And once again, only one option. Unless you really wanted to mess with that tangent squared on the bottom, because it is a tangent squared and a 1, right? But then that brings secant into the, right, from the identity, and I don't think we really want to do that. Where on this last one, we brought these back in because on these bottom 2, to get cosine of 2 theta, I either need just sine or just cosine. Where on this one up here, I need both sine and cosine. So that's why we brought in those identities on this one. Okay. Where with tangent, probably not a good plan. You could if you want to, but probably not a real good plan. Okay. Any other questions? You had some good ones. No? All right, so we just did a little bit of deriving there today. It didn't take too long. So let's go at this one here. So it's if cosine is square root of 5 over 5. Well, that's not one of our common ones on the unit circle, is it? And theta terminates. What's that mean again? Terminates. Yeah, ends. Very good. In the first quadrant. Then determine the exact value of each of the following functions. So I can draw a picture that represents cosine of theta. But if I drew a picture, am I going to be 100% perfect with my picture? Probably not. So then they're asking me down here for letter A to find cosine of 2 times that angle. But you see what I mean? If I draw a picture and it's not going to be very accurate, you see how algebra is beneficial then. Because I don't know. If I double the angle, I don't know where it ends up. Okay? So let's start by drawing ourselves a picture for that so that we can see what's going on. Okay? First quadrant. Again, we're going to put theta right there. We've been doing this for a while, right? So now we're going to kind of combine the algebra and the picture. And we know it's first quadrant because it told us. We need to do cosine of square root of 5 over 5. So can I just put that information wherever I want, or there's specific spots they have to go? So for example, where should the square root of 5 go? Don't point and say there. In the bottom, okay. Square root of 5, and then the 5. Hypotenuse, okay. Uh-oh. I don't think we're going to find this on the poster of the triples. Okay. And so we are going to have to do Pythagorean theorem. So I don't know what you want to call that one over there. We'll just put maybe an x there for right now. So it's the square root of 5 squared plus x squared equals 5 squared, right? Find out that other side. Well, this actually doesn't end up too bad. Square root of 5 squared is just 5, right? Plus x squared equals 25. Subtract 5. X squared equals 20. Take the square root. X is, now technically it's positive or negative, but which one are we going to use? Positive, because it's into the first quadrant, right? And so positive square root of 20, but I believe square root of 20 does simplify a little bit for us. So if I had square root of 20, I can break it down into square root of what times what? 4 times 5 is the beneficial one, right? We could do 2 times 10, but that didn't help, right? So this is 2 square root of 5. All right, so 2 square root of 5 for that side. So now this is the one where we have to pick which one we want to use. It really doesn't matter. It's more of a personal preference of the cosine formulas. We have many of them. Should we just use the first one that popped up just to use it? Which is what? Cosine squared minus sine squared, right? That's from the other side of your notes. We figured that out. Or, again, the way I think a lot of you prefer to see it, like that. Okay, same thing. So again, I'm finding this angle doubled. If I'm in the first quadrant and I double the angle, where can I end up? Where's it possible? For example, can I end up in the fourth quadrant if I double a first quadrant angle? A bunch of people shaking their head no. No, because basically you can't go above 90 and you can't go less than 0, right? And then you have to double them. So what if I had 20 degrees and I double it? Where does that end up? First quadrant. What if I take 80 and double it? I end up in which quadrant? Second. Can I end up in the third? Is that possible? Can you get that far? So this doubled angle is either going to end up in the first or the second. It has no other choice. Okay? So let's go find out here. Do I know cosine of theta? Again, just theta, not 2 theta, just theta. I do. That's what this picture is all about, isn't it? So it is cosine. It is square root of 5 over 5, which I have to square minus. Do I know sine of theta? we can figure it out. Right? If we go over here and do opposite over hypotenuse, right? So 2 square root of 5, that's opposite over hypotenuse. So it's 2 square root of 5 over 5 squared is going to equal cosine of 2 times some angle. I don't even know what that angle is. Well, what is square root of 5 over 5 squared? You can just square the top and bottom separate. So let's square the top. Square root of 5 squared, that's 5, over that squared is 25. I wouldn't simplify that if I were you. Can you see why? Yeah. If you look ahead, we're probably going to get a common denominator without even trying, right? Minus, uh-oh, be careful on this one. What's 2 square root of 5 squared? You got to square the 2, and you got to square the square root of 5. So the square root of 5, that was loud. Yeah. Square root of 5 squared is 5. Square root of 2 squared is 4, so 20 over so cosine of 2 theta is what? Negative, see again, common denominator, that's why I wouldn't mess with it. Negative 15 over 25, which simplifies to 3/5. Is that right? So cosine of 2 theta, negative 3/5. I know that's just a bunch of algebra, but you just found the cosine value of the double of an angle that you didn't even know. You never knew the angle, yet you were able to find the cosine value of that angle doubled. So which quadrant did it end up in? First or second? And how can you tell? Yeah, cosine is negative, so it must have ended up in the second. Okay. Wow, that's a really bad negative 3/5. All right. Questions on the work that we did there? Yes. Yes. Oh, okay. The question was, why is kind of this flipped around on these bottom two down here? It boils down to, if I go back to this formula, okay, and what I'm going to do is I'm going to replace sine squared. So I'm going to replace it with 1 minus cosine squared. So if I put 1 minus cosine squared there, it'd be cosine squared minus 1 minus cosine squared. And so you see if I distribute this, it becomes a negative 1 and a positive cosine squared. So I just chose to write it that way. I could have put negative 1 plus 2 cosine squared on that second one. But if I put it together, it is actually 2 cosine squared minus 1 if you actually distribute that negative. Good question. Now, could I have used one of these other two and gotten to the same answer for that last problem? Yeah. Okay. And in fact, I was seeing if anybody would notice it, and I thought that's what you were going to ask. I could have used this formula, and I wouldn't have had to have drawn the picture. I already know cosine. It would have gotten me to the same answer. Okay. But any of the three work. Whew, that was a lot of work. All right. Sine of 2 theta. Well, at least we don't have any choices. And we already have our picture, but I don't have it here, so I'm going to draw it again. Right? That's the picture for theta, not 2 theta, just theta, not the double one. And so seeing we don't really have a choice, let's just start replacing stuff. 2 sine of theta is 2 square root of 5 over 5, right? Opposite over hypotenuse. It's the same thing it was last problem. And then cosine of theta is square root of 5 over 5. See, once you have the picture going, it really doesn't take very long to do these. Now, I know some of you would like to write this 2 over 1, right, because you're more comfortable. All right, let's be careful here. Multiply the numerators. I've got a 2, a 2, a square root of 5, and a square root of 5 that I'm all multiplying together. So 2 times 2, that's 4, right? And square root of 5 times square root of 5 is 5. And so we're looking at 20 over 1 times 5 times 5 is 25, so otherwise known as 4/5. Wait a minute. We knew 2 theta ended up in the second quadrant. Does sine being positive make sense? Oh, it actually does. That's right. It's only cosine. Okay. Which leads us to this one. Any suggestions of how we tackle this one? Or would you like to just use the formula just to see how it works? Use the formula, see how it works, and then I'll show you the way I would have done the problem? How about that? Okay. Well, here we go. Again, we're drawing our picture for theta. You already have it. You don't have to draw it again. I almost forgot what it was, but there we go. All right, here we go. So we got to take 2 times whatever tangent of theta is. Tangent is opposite, right, over adjacent. So it's 2 square root of 5 over the square root of 5. We agree that's how you would find tangent, right? What very nicely happens there, and we will let it. So tangent of theta is just 2 over 1 minus, again, this is asking for tangent of theta squared, right? Well, tangent of theta is just 2. We already figured out what it was, right? See, tangent of theta right there is just 2, which we can square. We got 4 over, well, this would be 1 minus 4, right? So -3. I'm very squeaky with my shoes today. It's very humid in here. All right. Any other ways we could have done that one? Yes. Yeah, we already figured out, because tangent of 2 theta is still equal. This kind of goes back to the question earlier. Can we avoid, isn't tangent of 2 theta equal to sine of 2 theta over cosine of 2 theta? On this sheet, do we have the answer for sine of 2 theta? Given the starting theta. We do. What was it? It was 4, wasn't the last slide 4/5? Is that what it was? 4/5 over, we already have cosine's answer for this particular setup, right? And so it was -3/5, right? Do we see this becoming that answer? Yeah. Okay, use all of this stuff, because then we're going to multiply by that, because this green is just 1, right? And that's why we do that. Oh, hey, just keep going. And there's your -4/3. It works out really well. Any other questions on that? No? Oh, I've had some very good ones today.